Okay, this is June 2010, question 8 from the revised specification. This would be module 3. Name the most likely nuclide used as fuel in a fission reactor. Well, that's very straightforward, uranium-235. In the fusion reactor is deuterium and tritium. The deuterium coming from heavy water, the tritium produced in a reaction from lithium inside the reactor. The subatomic particle involved in fission is the neutron, and why is its kinetic energy altered? Well, it's altered to slow the neutrons so that they may be captured. Now, why do they need to be captured? So that they allow capture, and they need to be captured so that they can enhance that reaction. So how do they do that, and how is that achieved in practice? Well, they introduce a moderator, and the moderator can be carbon, water, so it's either carbon or in the form of graphite or water as the moderator. And that then what happens is that the neutrons are slowed by collision with the atoms in the moderator. Okay, so that's what happens there. Name the particle in the fusion reactor. Well, it's the ions and the protons in particular, because if it's a fusion reaction, it's hydrogen ions, which are protons. And in what way does the kinetic energy need to be altered, and why is it altered? Okay, so the kinetic energy needs to be increased. So the kinetic energy of the protons is increased. And why? And that's so that they can overcome the electrostatic repulsion, and that's what you need to do, so that they can overcome the electrostatic repulsion. And remember, you need these two to come together. So you need this proton and this proton. Okay, they would normally repel each other, but you need to give them enough kinetic energy, so that they overcome that electrostatic repulsion and therefore fuse together.